Hello, how y'all doing today? My name is Bernie Thompson, and today we're here to take a look at a 2004 Infinity FX45. This Infinity's problem is it has a high idle, and the customer wants this vehicle fixed. So the first thing I want to do is I want to grab a scan tool and get it into the vehicle and get some basic data so we can try to figure out why this engine has a high idle. So let's go ahead and get the scan tool. I've gone ahead and I brought the scan tool up and I went ahead and pulled the DTCs. We have a P0301, a misfire on one. We have a code for the intake cam on bank 1 control. We have a code for the intake control on bank 2. We have a code for the circuit on bank 2. We have an ISC code. This is an idle code. The P0507, guys, that's what I was here to diagnose, is because the vehicle is idling high, and I can clearly see at 1700 it's idling high right now. But you can't get this system to learn an idle control if the cams are out of time. So really, I thought I was just going to work on an idle speed control problem on this car, but really I have some kind of cam error on this car. So what we want to do is we want to go out, I want to go to the active test, I want to go over here, and we want to select this. Okay, so here we have our trims and where we're at. Now this is telling me my crank angle of bank 1 and this is bank 2, and basically the cam says it's a 50 and this is -8. So I'm not sure what's going on, but I'm positive that something's wrong with the cam systems. One of the cams is out of time. I really don't feel misfires, it just idles really high. But what I want to do is I want to go ahead and we need to put a scope on this car so we can properly diagnose whatever's wrong. But there's some kind of a cam issue here. So let's go ahead and get the scope connected. Due to access, I can't quite get to the crank sensor on this engine in the back, so I drop the glove box down and the PCM comes out very easily. So we connected channel 1, it's yellow, and we connected it to the crank sensor. We connected channel 2, it's red, and we connected it to the cam sensor also at the PCM. Both of those are in the back of the engine. We've gone ahead and we've connected channel 3, which is green, to the cam phaser sensor on bank 1. We've connected channel 4, which is blue, to the cam phaser on 2. We've connected channel 5, which is white, on the VCT control for bank 1. We've connected channel 6, which is purple, to the VCT control for bank 2. We've connected channel 7, which is orange, to the ignition event from number 1 cylinder. We've connected channel 8, which is brown, to the ignition event on number. Now that we have our leads connected, let's go ahead and get the data up on the scope. We have the scope up, so let's go ahead and get some data. I want to go to measure and deep record. I want to just record a small section of this. I want to take my zoom window, and now is what I'm interested in, is zooming in on this. The first thing I can notice is this white and purple trace that are on the top. That's the control system for the VCT. That's the variable cam timing solenoids. Those are pulsed, this will pull down to ground, and that will allow current to go through the solenoid and it will open up. When it opens up, it allows high pressure oil flow to go up to the cam phaser, and it moves the vane motor in the cam phaser. So there's a vane in there, and if I put more oil pressure on one side, I force it one way. If I put more oil on the other side, I phase it the other way. So this vane motor is going to be how I'm going to control a cam. Now these are not being controlled, and I think that's okay because we have DTCs for the cams having problems. Now if the computer thinks the cams are out of time, it's going to stop controlling them. So I'm not going to worry about this right now. So the yellow trace is the crank sensor. Let's go ahead and shut it off. Now the red trace is the cam sensor, and the green trace is the phaser sensor for bank 1, and the blue trace is the phaser sensor for bank 2. Now notice we don't have a cam sensor for bank 2. We only have the cam sensor in red on bank 1. They're going to use that to make sure where the cam locations are, and then they're going to use the cam phasers to target where each cam is actually located. Now, I don't have any data for this vehicle. I don't know where these cams should be. But what I think is wrong is, let me shut off this. Do you see the orange marker? That's the coil, ignition coil fire for number 1. On the falling edge lines up with the rising edge of the phaser. I think the blue target, the falling edge of the brown, which is cylinder 2 ignition fire, should line up with this edge right here. So what I want to do is I want to go ahead and get my cursors, and we want to get one fire cycle. So I want to go to where the orange drops, because that's when we fired, and now I'm going to go mark this. So now we've got the pink markers on this where we can have this marked. Now, do you see where this marker right here falls on the falling edge of cylinder number 2 fire? I think that blue trace should have its edge right with this one, like the orange one does. Now, I want to get the cursors, and now's what I want to do, is I want to measure from the brown one to the falling edge of the blue one. That's the difference between those. And do you see how I have basically 39 degrees? So that's telling me that that's 39 degrees out. Now, one cam was out like 8 and one's out 50. That could be about 40 degrees of difference. Now, that was what the scan tool said, so that's pretty close to where I think that should be over here. So I really don't know. Now, that would either tell me that bank 2's cam is off or bank 2's phaser's off. Now, the scan tool is not going to help me, and I need more data from an oscilloscope. Right now, I know I have a cam phaser issue. The phaser marks aren't where they need to be. That's why we're setting a code. So what I want to do is I want to go and I want to get the pressure transducer in the cylinder for number 1 and the cylinder for number 2. That's bank 1 and bank 2. And then I want to compare them to see if the cams are out of time. Now, the engine has a real high idle, so it might be hard to feel a misfire, but it really doesn't feel like it's misfiring, like a camshaft is off, but the cam could be off and it's idling so high I just don't really feel. It might be partial fire, partial misfires. So that being said, to get the data that I truly need to make the proper diagnosis, I need pressure transducers in these cylinders in each one, and we need to look at the data, and then we need to figure out why this is off. We also want to put a wire on the control of these cams, and I want to activate the phaser to make sure the phaser's not stuck. In other words, if the phaser can't move, I would also have a problem. So let's go ahead and get that done, and then let's look at that data. I put a tailpipe pressure transducer in the tailpipe with a hose. That'll give me the exhaust pushes. To get the intake pulls, we're using a pressure transducer, 30 inches of mercury. I took the spark plug out for the in-cylinder reading. We're using a 300-pound pressure transducer that's in the cylinder to get that reading. Now, let's go ahead and get the scope set up so we can get these readings. Now we have the pressure transducer in cylinder 1. Let's go ahead and set the scope up for that. First thing I want to do is we're just going to make this a 4-trace to make it much easier to deal with. In channel 1, we have the tailpipe pressure transducer. In channel 3, we have a 300-pound pressure transducer, and in channel 4, we have the 30-pound pressure transducer. We want to go ahead and zero these out now, and we want to add these traces back in. Let's go ahead and start to get the data. We're going to start the car up. So we're going to stop it. We're going to go ahead and we're going to get a small window here to where we can look at this. Going to mark the cam. The pink markers are the top and bottom dead center points. So this is top dead center, bottom dead center, top dead center, bottom dead center, top dead center. Each one of the lower marks is 30 degrees. So the first thing I want to do is I want to come to the bottom dead center mark and look at where that exhaust valve opened. It opened right at the 30 and it goes almost to the top of the point. So that's right, because my target is 30 to 50 degrees. That's rule of thumb, so that's matching that. If I come over here, I can see where the actual drop came a little after top dead center for this, and I can see my 30 degree line came up a little ways into the ramp, and that's about right. I come over here and I can see where this started to rise right at about 55. Now, since this is what we're interested in, I want to put one mark right at the bottom dead mark, and I want to put the other mark right about where that looks like it's going to happen. And that's right where I get a little bump, but it goes flat and it starts to rise. Now that's 60 degrees, so the piston has been moving up for a while right here. And then when the valve actually closes, I start to build pressure because the piston is moving upward, changing the volume within that cylinder. So right here we can see that we have about 54, 55 degrees. So that's also within target, because about 40 to 60 is my rule of thumb on this. So this cam, by rule of thumb, it's correct. It seems right. Now the other thing I've done is I've gone ahead and I've gotten into the VCT, the variable cam timing solenoid, and I've got it to where I can ground it. So we want to go ahead and we want to do this. Here we're grounding it. So we'll let it off, and you always want to make sure that they come off pretty quickly. If they don't drop right away down, you got one that's sticking. But right now, I'm just interested in how far it's moving it. So here we're going to do the same test. Basically, we're going to go ahead and get our cursors. We're going to put our cursor through the peak, and we're going to put our cursor through the peak. We're going to go ahead and mark it. And then we're going to go ahead and move this up. And what we can see right here is this whole ramp moved to the left, so that's advancing that cam. Now if you notice that right about where the top dead center mark is coming through the bottom of the ramp, it used to be over here at 30, so that moved about 30 degrees. The next thing I want to notice is right through here. Do you see how this is just dropping the whole time? So this drops all the way down, and it keeps dropping until, let's measure this. So somewhere right about there, okay, so that's basically 30 degrees. So this has moved 25 to 30 degrees right here. Do you see how this still ramps down until this point right here where you get a little hitch? That's how far that cam is moving. So basically, this cam phaser can move the cam, if I apply it, about 30 degrees. So the cam timing is where I would expect it to be, rule of thumbs, and the cam phaser is working about where I would think it would work to, about 30 degrees. So cam phasers usually move somewhere between 30 and 50. Those are real normal numbers. So more than how far it moved now, I want to go and check bank 2, and I need to see if the cam in bank 2 is off or it's on, and I need to see how far that phaser can move. Now, the way you're going to figure this out is comparing bank 1 to bank 2 with the in-cylinder pressure, both by the pressure and by the cam phasement moving. How far did it actually move? Those two things will give me the data that I need to figure out what we're going to have to do to fix this car. So let's go ahead and move the pressure transducer from cylinder 1 to cylinder 2. Okay, so I've taken the 300-pound pressure transducer from cylinder 1 and I've moved it over here to cylinder 2. So now we'll get the in-cylinder pressure readings from cylinder 2. So let's go ahead and get that data. Okay, so let's go ahead and get the data from cylinder 2. Want to go ahead and stop that data. Get the cursors, put it through the peak, get the cursors. mark the cylinders. Okay, now bank 2 on the exhaust is in the same place. The pocket is right at 30, and we come to the top with the exhaust plateau right on the bump, and that's the bottom dead center mark. Again, we're having the intake open slightly after the top dead center where it drops. We have a pretty much complete drop, or a long ways down to the 30 mark, and we come over, and once again I can see we're going to get the cursors and we'll actually measure this because we're dealing with the intake cam timing here. So what I want to do is I want to come over here and I want to mark that. Do you see how we came down and this stayed flat right until about that? And that's 58 degrees. So the other's about 55. So the two cams are in time. The two cams are not different from each other. They are the same. So what we want to do now is we want to go ahead and we want to activate the VCT solenoid. So we're going to go ahead and start it, and we're going to go ahead and we're going to ground that out. So that's fully grounded. So now is what we want to do is take the zoom window. We want to look at this where we have the ground applied. That's applying the solenoid to let the pressure. Is what we're trying to make sure here is that the phasers are in operation. We need to make sure that the phasers are working. So we can see that we moved this back from in front to over here. We can see that before, that 30 mark was about the same as where the top dead center mark. It moved about 30 degrees. And again over here, let's get our cursors and let's actually measure this. So that's where it was before, and we can see we're still dropping till about right there. We move that cam about 30 degrees. Okay, so what that tells me is that the two cams are the same, they're in time, and the two phasers can move these two cams the same amount. That means that the target wheel on the phaser, something's wrong with the target wheel. The target wheel has moved for the phaser from the camshaft. So I want to go take a look at what's involved in getting to that phaser, but that phaser is what the problem is. The target wheel moved. So this is how you would figure one of these things out when you don't know where the markers are. So now we clearly have an indication of the phaser has something wrong with its target wheel for bank 2. Bank 1 is on, bank 2 is off, and this is a phaser target wheel problem. So let's go out and take a look at what's going on with that phaser. This is the cover system for the cam phaser on bank 2. I want you to notice that right in here you can see that there's heavy silicone that's been added. So that cover has been off. That is not stock. Somebody's had that cover off. Now when you look at bank 1, we can see that that has not been off. That's a factory seal on that guy. But on bank 2, we have a problem because somebody they've had this cover off. It's been removed. So what I want to do now is I want to take this sensor out on top, and I just want to take a look down through the sensor hole to see if I can see anything with that target wheel. So let me get that sensor out. So I'm using the ATS inspection camera, and I'm looking at the target wheel here, and you can clearly see where someone has been prying on that target wheel. They've actually bent the indentations on that target wheel. I mean, why would you do that? I mean, you just never know what you're going to get when you work on cars. Every day I come out here and I find some pretty crazy stuff. But this is self-induced. Someone did this to this car when they had that cover off. It looks like they used the target wheel to hold something or pry on it. Irregardless, the target wheel has moved from the camshaft. Now that means that this is going to need a new cam phaser because the target is part of the cam phaser. So the shop will take that cover off, they'll replace the cam phaser, and this vehicle will be ready to return to the customer. I'm back at the shop for this Infinity. They've had to tear the entire front of the engine off to get this phaser in. This phaser, this is the target wheel, it's made on the phaser. This notch is not in the proper place according to this line. Putting a new phaser on this car has fixed it. So now the car is taken care of. I went ahead and I connected a scope so I can show you the difference. Channel 1, yellow, is the CKP. Channel 2 is the cam sensor, and that's in red. Channel 3 is in green, that's the phaser for 1. Channel 4 is blue, that's the phaser for 2. Channel 5 is on the ignition for 1, and channel 6 in purple is for the phaser on number 2. What I want to show you is what we were off last time. So right here we can see where I have my phaser target and I have my ignition. Now we have my ignition and my phaser target here. Before, this phaser target wasn't over here on the ignition, it was way over here. Now that created a problem for the car and for it to be able to run and drive properly and not set codes. Now that they've got it in, it's all fixed. The idle is taken care of, so this car is ready to return to the customer right now. What I want you guys to take away from this is you need to really think logically on a car like this. This is a really hard diagnosis, and you gotta be right, because that's a 16-hour job to get that phaser in, and it's an $800 part. You just can't afford to be wrong for yourself or your customer. We really need to use scopes, because you're not going to find this type of problem without a scope. Use your scope every day, get better at it, start to understand how I laid out this process. It is a very logical process, and it is event driven. I am doing a test that I understand why I'm doing the test, and I understand the data or the results of that test, and those results are guiding my next test. If you do this and you have quality equipment, you too will be successful in your service base.